Hello everyone. In this video, I'll be giving a demo of Dexter, which is a browser-based, domain-independent structure explorer. Now, the structured data that Dexter can be used to explore could be in the form of CSV files, JSON data, XML files, databases, web APIs, or even HTML pages. Let's go ahead and open up how Dexter looks like. In this video, we'll be covering Dexter's version 1. So when you open up Dexter, you encounter an empty page, and the simplest operation that you can do is to create a table. Remember that Dexter allows a user to browse a structured data as a table. No matter what the form of structured data is, it is converted to a table. CSV files to table, APIs to table. So Dexter browses tables in a relational data format as tables. So let's go ahead and create a table. The simplest way to create and populate a table is to fill in values into a spreadsheet. So Dexter tables can be of two types. Either they are base tables where the data is manually entered or it is imported from a file, or they could also be derived tables. We'll cover that in a minute. So the simplest way to populate a table is just to manually enter in some values. You can also change the scheme of the table to delete columns or delete rows. To delete a column or a row, click on the relevant row or column heading and press remove. Same goes for adding. This is pretty much self-explanatory. After you're done adding or deleting rows or making changes to the schema, you can also change the name of the table. And finally, when you're done with all the changes, you can go ahead and save it. When you save the table, it is saved locally in your browser. It's not uploaded to any cloud. It's not uploaded to any server. It is stored inside your browser. And when you refresh Dexter, the data is still there. It's being loaded from your browser's local storage. One of the requirements for you to run Dexter is that your browser must be compatible with IndexedDB and local storage. Almost all major browsers support that, so you should be good to run Dexter. The next form of structured data that we will be covering in this video is HTML fragments. Let's look at the faculty and advisors at MIT EECS lab. Now these are essentially div fragments. In Dexter, and there is an implicit structure to these divs, similar to XML. In the next piece of demo, what we'll be showing is that by just copying this DOM fragment, we can convert it into a nice looking flat table in Dexter. So to convert this DOM fragment, we select them all. And then copy them using the standard way. We go to Dexter, create a new table, and click on import or paste. If you wanted to import a CSV file, we would click on choose file, but since we are just pasting the web fragment, we click on this input field and press paste. After you've done pasting, we click extract and then click done. And there we have it, a nice looking flat table. Let's go ahead and give the column heading some meaningful names, like name, affiliation, and so forth. And let's give this table a nice name called MIT or something. Yeah, MIT faculty might be more appropriate. So in addition to doing all this, you can also sort a column by its values by just clicking on the button next to the column heading. So when we click on the sort button next to name, there's a lag in the video, so it's taking time. you'd note that the name has been sorted in descending order. If you click again, the sort order toggles. Now, in addition to sorting and populating from tables, let's first go ahead and save this table first. So this is another example of a base table that you can create in Dexter. Now let's actually go ahead and create an example of a derived table. So just reload it. It's something is weird with the web page. Yeah. So for in the apparently the name was not correctly saved. Yeah. So you note that in this table, the last column lists the areas of interest for these professors. Like some are interested in nanotech, some are interested in cybersecurity. Now, a professor can be interested in multiple areas, and all of them are listed using commas. So let's try to create a tuple for each professor research area field. And the reason why we are doing this is to will become clear later. We essentially want to find out which are the hot areas, which areas have the highest number of professors, and so forth. So let's go ahead and create a derived table that can do it. The first step is to create separate tuples for each professor and research area pair. So let's call it faculty by area. Now to create this table, we essentially need to project the name of the faculty and the area, and the area is obtained by splitting the last field of the MIT faculty table using commas. To split the column, we use a inbuilt predicate called split. By the way, the rule that we are writing is an example of a logical rule that can be used to create a derived table in Dexter. To recap, Dexter allows a user to create two types of tables, one of which is base tables, similar to base tables in databases, and derived tables similar to views in databases. Views can be created by writing dexlog rules, which is an extension of datalog. Details about dexlog can be found in the Dexter's project page, and what we've written here is an example of a dexlog rule. Now, in order to make it easy for people to write dexlog rules, we have the autocomplete feature in the Dexter rule editor, which is essentially the text area above the spreadsheet-like interface that you saw earlier. And this auto completion can be triggered by pressing control space. To take a very small example, so let's see what this rule does first. So we are looking at for all bindings of name, affiliation, CD, and E and F, we want to split the the value of the F attribute by commas and call them area. So this rule should generate a name and area pair for all professor and their research areas. Let's go ahead and evaluate this rule. There we have it. So for example, Scott Aronson has three areas: CSI, AIL, theory, and nanotech. So similar to databases, you will see that derived tables or views, they are colored differently, and you'd see that they are read-only, unlike the manually created tables. Because you cannot really change a view you cannot really edit a view. They are derived using logical rules. The only way to influence the value of a view is to change this rule. However, similar to databases, you can also materialize this view. This operation is called pinning a table. When you pin a table, you'll see that the text becomes more black, and let's go ahead and save it. And when you refresh this page, you would notice that you don't have to evaluate the rule again and again to get the answers. This is essentially for efficiency reasons, nothing else. So now let's go ahead and find out which area has the maximum number of faculty. To do this, essentially we have to group by area and construct the set of all faculty names and then perform a count operation. So this will be an example of how do we do aggregation in Dexlog. So let's go ahead and create a table. Let's call it aggregate. So I've pre-written the rules just for simplicity in this demo. So first we find the list of all areas by projecting out the areas from the previously created table. And then for each area, we find the set of faculty and we group them in a variable called set. The constructor that I'm using set of is an extension to normal data log. It is essentially a second order constructor that computes sets of values and tuples. So let's first project this set and then we'll perform an aggregation operation on it. When we evaluate this rule, you see that for each area you get the set of faculty names who are associated with that area. So instead of names, let's actually get the count. There we have it. For CSAIL, and let's sort it by the values. So it turns out CSAIL is the most popular research area. Let's go ahead and pin this. In addition to computing aggregates, Dexter also allows you to create charts out of the data that you are doing. So this is a functionality provided by the charted feature. So when you click charted, interface opens up on the bottom of your screen. Let me just refresh the page. There is some lag issues. Yeah. So when you click charted, there is an interface, there is a UI that opens up at the bottom of the table. So suppose you wanted to plot a bar graph between the different research areas and the values. So A is the x-axis, B is the y-axis, and chart type, make it a bar chart for instance. So you've created the chart, now you can export it and so forth. To close this interface, you can just click charted again and there you have it. In addition to writing Dexlog rules, creating derived tables and all, you can also do rudimentary filters using Dexter's user interface. When you click filter, you can create filters on, let's say, the number of people in a group. Since it's a numeric field, Dexter does very basic type identification between number and strings. For numbers, it's mostly ranges and equality. For strings, it is just a selection. So let's say we want the research areas where there are more than 50 faculty. So CSIL is the only research area, and you can remove this filter as well, in which case you get back to the original view. Now we've covered simple selection, we've covered projection, we've also covered aggregation. Now let's look at a simple join between two tables and how that can be achieved using Dexter. So we imported in the MIT faculty, and here's a table of all the Turing Award winners. I know for a fact that this year the Turing Award winner was Michael Stonebreaker, and he happens to be a MIT faculty. So let's see if we can get to this join using Dexter's rule editor. So similarly with the MIT case, let's copy this DOM fragment and paste it as a Dexter table. Let's call it Turing. We don't really need the description of the Turing Award winners, however notable they might be, because for this video we just need to perform the join. So now we note that in some years there are more than one Turing Award winner, and these values are separated by a space and the string A and D. So first we need to clean this table. So let's first save it and then clean the table. Turing 1. So we want to split the second field using the string space and AND. Let's see if this cleans it up. There we have it. So now let's try to perform the join. Let's go ahead and save this. So the table that we are interested in is MIT Turing. To get the list of Turing Award winners from MIT, we need to look at all the Turing Award winners and see which of them are from MIT. There we have it. Turns out that there are 3 Turing Award winners from MIT. Note that in this join, we are not certain. There could be more people who won Turing Awards, or they could not be. In this case, we are just basing our data cleaning on the assumption that name is a good indicator of resolving entities. But regardless, Dexter is not a tool for entity extraction. It is just a rule for performing relational joins, relation operations, and exploring your data. Okay, so we've covered joins, we've covered aggregates, we've covered the basic operations. The other simple operation that you can do in Dexter is to export a table. To export a table, simply click on the menu bar, click on export, and then you can export it as any popular format like CSV, JSON, or XML. Some more minor notes. You can also connect to APIs and databases, but we are not covering this in this demo. In addition to that, by changing the prefix of a table name, you can create folders. Folders are essentially a way of grouping your tables. The shared folder is actually a it's a very own server where if you want to publish your own table so that other people can view it, so the folder shared is special for that reason. Because note that in Dexter, nobody else sees your tables. These are your own tables. These are only accessible within your browser. Somebody else who is opening his or her browser cannot access that table. So for if you want your table to be shared with a friend, you click on table and click on share. So that's about it. There are a couple of more things that we didn't cover in this demo. For example, how do you write validation constraints in Dexter, and how do you connect a database and so forth. For that, please consult the Dexter user manual, or you can also click on the help button here that opens up the help page in Dexter.